Hi, my name is Nick, and this is a talk on measuring aesthetics. It's a talk on UX, and I've been thinking about UX a good amount because I've been hearing about it a lot. So it seems like a pretty hot topic, but I've been thinking about what user experience actually is and what the design of web apps is. Because the concept is thrown around a lot, but I don't really know how to use it to really better design my apps with. It seems a little elusive to me. So I've been thinking about what makes a great UX and what components results in making a great UX. There's a lot of great apps out there, but what makes them perform well and what makes it stick with the user? So I've recently heard from a great artistic director, you might know him, his name's Otter. He described UX as designing for happiness. And I thought, okay, that sounds like a pretty good end goal. But how do we get there? This is how I kind of think about UX in a nutshell. We have the functionality of the app. Then we have the design, which the functionality is kind of filtered through and transcended through, and then it ends up a user experience, and somehow this results in happiness. So that's kind of a good idea of it, but we are programmers, and we are engineers by and large, so this is very qualitative, but how do we quantify this? For programming, we think about numbers, we think about the actual runtime. But how does UX fit into this? So I've been thinking about that a lot, and what's really great, and I'm happy to announce today, is I have discovered a whole new branch of mathematics, late at night, laboring away. So we've had Big O for a while, but for UX, I've discovered, and I'm pleased to share with you today, is Big U. Big U, and this is it's a Greek symbol, it's a mathematical notation of how we can kind of quantify user experience. And it applies to elements and actions that are done on a near daily basis. So a good example of that is if you have an email program, you probably are composing an email or reading an email. So let's dive a little bit into Big U. By the way, Big U is spelt with the letter U, but it's also like you as in focusing on you, the user. So there's a little play there. So we have some different inputs, just like we have with Big O. With Big U, we have clicks, that can be an input. We have grouping and distance, that can be an input. And visible features, that can be an input. And just like Big O, with Big U, we have, Big U of 1 is really great. And then there's an example of what's not a very good Big U. That's a user experience complexity. That's something we want to avoid. So let's look at these 3 different concepts, and we can try to measure how these can create a good user experience. So we're going for clicks. This is a great basic way to start thinking about your app and how you can make it more accessible to the user. So every click after the first is an input of n. One click would be a U of 1. After that, n and n squared, etc. And just like with Big O, you want to keep it to a minimum. This is a great example of the standard old legacy HTML input. You upload, you choose a file, you click there, then a dialog window opens up, you click there, you click OK, and then you have to click Submit. So that's a really bad UX complexity. Something that Facebook does is you can just kind of drag things onto it. That's basically constant time for UX complexity. That's one. That's a really great way to do that. So these more interactive drag and drop features are usually really great for a problem like this. We have grouping and distance. This is another type of input for Big U. And it was resulted from me reflecting on Fitts' law. The time to acquire a target is a function of the distance to and size of that target. So this is really important, especially when we're building desktop applications, not so much mobile. The way I can quantify this is we have small targets, they're an input of m, and every quadrant the user traverses is an input of m as well. So if you have a small target and we split the screen up into 3 quadrants, I made you look at 3 different spots of the screen. If you were to track that with your mouse, that's a lot of movement. That's basically an input of m cubed. So that's not very good either. We want to keep this in a small group. Here's another example, and this is something. A new interface that Google is starting to do. We have the mobile app that's on one side, and then the desktop app on the other side. So on the mobile, you see there's the plus sign on the bottom right corner. And with the new desktop app now, Google's trying to mimic the same user interface of the mobile. So you have, if you look, you see the plus sign is also there as well. But for the desktop app, this is a bigger problem because if I'm on my inbox and I'm on like the snooze and done, if I'm basically like way up there, I need to traverse basically across the entire screen just to compose an email. That's really not good. Sorry, Google. That is really not, and it's a complexity of like m cubed. So I would highly suggest a different approach, like the desktop app there. Finally, the idea that I can stay on the screen here as well is the idea of visible features. There's definitely a trade-off. We want to stay clean. We want to stay. We don't want to overstimulate the user, but we also want to make sure the very important features are visible. Now, this part of the mathematics is still getting fleshed out. As I said, it's a brand new branch of mathematics, so this is still a little qualitative. But we basically got to think, what is the inputs that are happening on a daily basis, and where are they accessible? If we have to look for something or search on a help page to then link back to where we need to be, that's the worst. That's like factorial. You don't want that for a user complexity at all. So back to this idea again, and this is why I think user experience is so important. Again, we have the functionality, the design that it's filtered through using our new great mathematics, and then we have user experience. But one thing to really point out here is that the user experience only sees the design. It would be lovely if we could demonstrate the full functionality of our app without the design, but most users don't like looking at a terminal, for example. So everything, the functionality that we have, it's all for naught if we don't have a good design to portray it in a way that the user can deal with it as if they knew what the actual application is. And I think that's the whole challenge with us as programmers, is to make the user feel as empowered as we do when we write the application. This is one more example of Microsoft Office. It looks a little busy, but I actually think this is a really great case study for visible features. We have our home, we have our tab data. If you've ever used Microsoft Office, you've definitely used this before. Things are grouped really, really well. And this is a very, very complex program, but there's a good amount of visual cues, icons. All the functionality you need is at the top of the page, so you have a U complexity there of like constant time or maybe just N, which is pretty good. They do a really good job of compartmentalizing all of these. And I'm wondering why is this a good design choice? And how did they arrive at this? Well, as we know, Microsoft Office has been around before the era of editing things online, editing documents online. So they didn't really have to conform to all the web standards. They could kind of go about it just at a completely clean slate way and say, what's the best way to use all these functionalities? I want to group them all in tabs up here instead of have like a hamburger menu or something like that. And I think sometimes taking a step back and making sure that the web standards are there because we do want to have web standards, that the design patterns are there, but making sure that our specific app and what it really wants to do is not being overshadowed by web standards for the sake of web standards. Again, we want the design to actually show the functionality because that's all the user sees. We don't want to show just the design without the functionality being filtered through. That's all for today. I hope you have enjoyed this new branch of mathematics, and we'll explore it further. Thank you. Any questions?